Hi students, welcome back to Learning Management System. Today we will discuss the third session of the second unit, that is fundamentals of the analysis of algorithm efficiency. So in third session we will discuss the concepts, that is orders of growth and worst case, best case and average case efficiencies. In the last session, that is in second session of the second unit, we discussed about analysis framework, measuring the input size, and units for measuring running time. These three concepts we discussed in the second unit. Today let us start the orders of growth. Orders of growth of functions, it depends on the input size. That is, the order of growth varies from function to function for an input size. Now input size ಅನ್ನು ಸ್ಮಾಲ್ ಕೊಟ್ಟಿದ್ರೆ ಸ್ಲೈಟ್ ಆಗಿ ಫಂಕ್ಷನ್ ಆರ್ಡರ್ ಕೂಡ ಚೇಂಜ್ ಆಗುತ್ತೆ. If you give large input, then running time will be large for different functions. So this behavior is shown in the table. So here you can observe the given table. The first row represents the various functions and remaining rows shows the values for the given input. So here it is the n, which is the input size, and it is a log base 2 of n, that is logarithmic function. This is linear function. This is also logarithmic function, followed by this quadratic function, cubic function, and this is exponential function and a factorial function. So let us take the first input size, says 10. If we give the 10 as an input for the logarithmic function, what is the output? 3.3. That is, output is reduced. For the second function, it is 10 to the power of 1, which is 10. And here it is 3.3 into 10 to the power of 1. And for quadratic function, this is 10 to the power of 2, which is 100. That is, for input 10, the output or the function value increased by 10 times. And for cubic function, it is 1000 times increased. 10 to the power of 3 means 1000. For exponential function also, it is increased 1000 times. Sorry, not 1000 times, it is 1000. And for factorial, 3.6 into 10 to the power of 6. So likewise, you can check for all the input values, you can check the outputs from the given table. So now let us consider Euclidean's algorithm problem, that is computing GCD of two numbers. Say 16, 20, 24. These two are the numbers whose GCD need to be calculated. So how we will calculate the GCD of these two numbers? In the first unit, you learned how to calculate the GCD of Euclidean algorithm. So first we find out the common factors of the first number, that is 1, 2, 3, 4, 5, 6, 10, 12, 20, 30, 60. And the common factors of second number, that is 1, 2, 3, 4, 6, 12 and 24. And what we take? We take the greatest common factor of these two numbers, that is for 60 and 24, which is the greatest common factor or the greatest common divisor, that is 12. So here you can observe for the number 16, how many common factors? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 common factors. And for 24, there are 7 common factors. For small numbers, we are getting less common factors. What if the input numbers are large? Say, I have two numbers, that is 10 lakh and 55 lakh. So by traditional method, if we try to find the common factors of these two numbers, then we will get more number of common factors. Okay. Here, input numbers are large, hence number of factors will be more, and number of steps taken by the algorithm will also be more. Hence, for larger input size, the order of growth of function will change drastically. So ಅದನ್ನು ನೀವು ಇಲ್ಲಿ ಚೆಕ್ ಮಾಡಬಹುದು ಟೇಬಲ್ ಅಲ್ಲಿ. You check here for the second input, that is 10 square. So here for factorial you can check it. For the input that is 100, what we are getting 9.3 into 10 to the power of 157, which is too big number. Okay. Hence, the order of the functions, it depends on the input parameter. For larger the inputs, more the time taken by the algorithm. So for these functions, these basic efficiency classes are the functions. Here we can represent their order of growth through a graph. So you can observe here the function big of log n, which is almost close to the input size. After that, linear function big of n. After that, n log n, followed by this exponential function. This is having more order of function than this function. Similarly, for the factorial function, this increases abruptly or drastically for very small input. So you can observe all the curves of the respective functions for the given same input size. Okay, students. So we can analyze the table or this graph. Algorithms that require an exponential number of operations are practical for solving only problems of very small size. Exponential ಅಂದ್ರೆ ಸ್ಮಾಲ್ ಇನ್ಪುಟ್ಸ್ ವ್ಯಾಲ್ಯೂಗೆ ಹೈ ಔಟ್ಪುಟ್ಸ್ ಅನ್ನು ಕೊಡುತ್ತೆ. From the table we can infer that the function log base 2n increases the value by just 1. So you can observe that in the table. Okay. The linear function n increases twofolds. The linear function n log 2n increases slightly more than the twofold. So ಇಲ್ಲಿ ನೀವು ಕಂಪೇರ್ ಮಾಡಬಹುದು. For the same input, big of n and big of n log n. ಸ್ಲೈಟ್ಲಿ ಚೇಂಜ್ ಆಗಿದೆ ಇಲ್ಲಿ. And next, the quadratic and cubic functions, that is n square and n cube, they increases 4 times 8 and 8 times respectively for the same input. Likewise, the magnitude of numbers from the table has a significance for the analysis of algorithms. So ಇಲ್ಲಿ slowest growing function ಯಾವುದಿದೆ ಟೇಬಲ್ ಇಂದ ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ that is log base to n. ಈ ಫಂಕ್ಷನ್ it is growing very slow. ಇಲ್ಲಿ ನೋಡಿ 10 to the power of 6 ಇನ್ಪುಟ್ ಕೊಟ್ಟಿದ್ರು ನಮಗೆ ಔಟ್ಪುಟ್ ಏನ್ ಬರ್ತಾ ಇದೆ 20 only. Hence, the function growing the slowest among these is logarithmic function. Okay students, now let us discuss the second concept of this session, that is worst case, best case and average case efficiency of various algorithms. Let us define worst case. Worst case efficiency of an algorithm is the maximum number of steps taken on any instance of size n. ಒಂದು ಅಲ್ಗಾರಿದಮ್ ಅನ್ನು ರನ್ ಮಾಡೋಕೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ನಂಬರ್ ಆಫ್ ಸ್ಟೆಪ್ಸ್ ಏನು ತಗೊಳುತ್ತೆ ಅದಕ್ಕೆ ನಾವು ವರ್ಸ್ಟ್ ಕೇಸ್ ಅಂತ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ. ವಾಟ್ ಈಸ್ ಬೆಸ್ಟ್ ಕೇಸ್? A best case efficiency of an algorithm is the minimum number of steps taken on any instance of size n. ಯಾವುದೇ ಒಂದು ಅಲ್ಗಾರಿದಮ್ ನಾವು ಒಂದು ಇನ್ಪುಟ್ ಕೊಡ್ತೀವಿ ಆಫ್ ಸೈಜ್ n, ಆ ಒಂದು ಅಲ್ಗಾರಿದಮ್ ರನ್ ಮಾಡೋಕೆ ಎಕ್ಸಿಕ್ಯೂಟ್ ಮಾಡೋಕೆ ಮಿನಿಮಮ್ ನಂಬರ್ ಆಫ್ ಸ್ಟೆಪ್ಸ್ ಏನು ತಗೊಳುತ್ತೆ ಅದನ್ನು ನಾವು ಬೆಸ್ಟ್ ಕೇಸ್ ಅಂತ ಕರಿತೀವಿ. ಅಂಡ್ ದೇರ್ ಇಸ್ ಅನದರ್ ಟರ್ಮ್ ಕಾಲ್ಡ್ ಎವರೇಜ್ ಕೇಸ್. ಸೊ ಎವರೇಜ್ ಕೇಸ್ ಅಂದ್ರೆ ಏನು? ಸೊ ಎವರೇಜ್ ಕೇಸ್ ಲೈಸ್ ಬಿಟ್ವೀನ್ ದ ಬೆಸ್ಟ್ ಕೇಸ್ ಅಂಡ್ ವರ್ಸ್ಟ್ ಕೇಸ್. That is, the average case of an algorithm is an average number of steps taken on any instance of size n. So, let us discuss these three cases with respect to one example. Let me take the example sequential search. So, here the pseudocode of sequential search is given. ಏನಿದೆ ಇದರಲ್ಲಿ? What is the name of the algorithm? Sequential search, which takes the input as an array and a search key k. It searches for a given value in a given array by sequential search method. What is the input? Input is an array and a search key k. What we are going to get output? This algorithm gives the output the index of the first element in A that matches k. So search key ಏನಿದೆ k, ಅದು ಯಾವ ಒಂದು ಎಲಿಮೆಂಟ್ ಗೆ ಮ್ಯಾಚ್ ಆಗುತ್ತೋ ಆ ಎಲಿಮೆಂಟ್ ದ ಅರೇ ಪೊಸಿಷನ್ ಅನ್ನ ರಿಟರ್ನ್ ಮಾಡುತ್ತೆ. ಅದರ್ವೈಸ್ -1 ಇಫ್ ದೇರ್ ಆರ್ ನೋ ಮ್ಯಾಚಿಂಗ್ ಎಲಿಮೆಂಟ್ಸ್. ಸರ್ಚ್ ಅನ್ನು ಸಕ್ಸಸ್ಫುಲ್ ಆಗಲಿಲ್ಲ ಅಂತಂದ್ರೆ algorithm returns -1. So let us see the logic of this algorithm. Initially we initialize I equal to 0 and we use while loop. We compare I with array size n. If I is less than n and a of I is not equal to k, if these two conditions are satisfied, then only enter into the loop. So ಎರಡರಲ್ಲಿ ಯಾವುದಾದರೂ ಒಂದು ಕಂಡೀಷನ್ ಫೇಲ್ ಆಗಿತ್ತು ಅಂತಂದ್ರೆ come out of the loop. So after entering into the loop, just increment I, that is I equal to I plus 1. So after coming out of the loop, compare the position of the I. If I is less than n, then return I, else return -1. Okay students. So here it is one example. Given array is, what are the elements of the given array? 6, 3, 0, 5, 1, 2, 8, minus 1 and 4. And what is the search key? That is 8. Okay students, so we compare 8 from the 0th index of the array, that is 6, 3, 0, 5, 8, sorry, 5 after 5, 1 and 2. So from 6 to 2 there is no matching with the search key. After this 8 matches with this 8. So the position of this 8 is returned as a I value. Now let us discuss the worst case, best case and average case efficiency with respect to sequential search algorithm. In the worst case, when there are no matching elements or the first matching element happens to be the last one on the list. For example, even array consider matter. The first matching elements, if it is the last element in the array, or if there is no matching, itantandra ಇದಕ್ಕೆ ನಾವೇನಂತ ಕರಿತೀವಿ? ವರ್ಸ್ಟ್ ಕೇಸ್ ಎಫಿಷಿಯನ್ಸಿ ಅಂತ ಕರಿತೀವಿ. In the worst case, when there are no matching elements or first matching element happens to be the last one on the list, then algorithm makes largest number of key comparisons among all possible inputs of size n. Hence, the worst case efficiency is, that is C worst of n is n. Worst case efficiency of linear search ಏನಿರುತ್ತೆ? n ಇರುತ್ತೆ. Next, let us discuss the best case efficiency of the linear search. Let me take another array, say 10, 20, 30, 40, 50, 60 and 70. These are the elements of the array. And what is my search key? My search key is 10. So after comparison of search key with the first element, the matching happens at the first comparison itself. Hence, algorithm returns the first index of the array. Hence, it is said to be best case. So minimum number of steps taken to execute the algorithm. So minimum numbers ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ? 1 ಆಗುತ್ತೆ. ಫಸ್ಟ್ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ಏನಾಗಿದೆ? ನಮ್ದು ಅಲ್ಗಾರಿದಮ್ ಸಕ್ಸಸ್ಫುಲ್ ಆಗಿ ರನ್ ಆಗಿದೆ. ನಮ್ಮ ಸರ್ಚ್ ಕೀ ಏನಿದೆ ಅದು ಮ್ಯಾಚ್ ಆಗಿದೆ ಮತ್ತು 0th ಇಂಡೆಕ್ಸ್ ಅನ್ನು ನಮಗೆ ರಿಟರ್ನ್ ಆಗಿದೆ. So search key 10 appears at the first location of the array, that is at a of 0. Hence, number of comparison is 1. So ಇಲ್ಲಿ basic operation ಏನಿದೆ? Linear search algorithm ಅಲ್ಲಿ basic operation is comparison. Comparing the search key with every key of the algorithm, every element of the algorithm. So the best case efficiency of linear search is 1. That is a constant value. Okay students. Next, let us discuss the average case. So determining the average case is little bit difficult for any algorithm. In case of linear search, except best case and worst case. Worst case ಅಂತಂದ್ರೆ ನಮ್ಮ ಸರ್ಚ್ ಕೀ ಲಾಸ್ಟ್ ಪೊಸಿಷನ್ ಆಫ್ ದ ಅರೇದಲ್ಲಿ ಇರಬಹುದು ಅಥವಾ ಇರದೇನೋ ಇರಬಹುದು. ಬೆಸ್ಟ್ ಕೇಸ್ ಅಂತಂದ್ರೆ ಫಸ್ಟ್ ಪೊಸಿಷನ್ಗೆ ನಮ್ದು ಎಲಿಮೆಂಟ್ ಪ್ರೆಸೆಂಟ್ ಇರಬಹುದು ಅಥವಾ ಮ್ಯಾಚಿಂಗ್ ಹ್ಯಾಪನ್ಸ್ ಎಟ್ ದ ಫಸ್ಟ್ ಕಂಪ್ಯಾರಿಸನ್ ಓನ್ಲಿ. ಎಕ್ಸೆಪ್ಟ್ ದೀಸ್ ಟೂ ಇಂಡೆಕ್ಸಸ್ index location remaining elements positions ಏನಿರುತ್ತಲ್ಲ that we consider in terms of average case efficiencies. Okay student, so here the comparison probability is distributed among all the possible cases. So the average number of key comparisons made by sequential search is n plus 1 by 2. Let us see how. So average case consider ಮಾಡಿದಾಗ this average case lies between best case and worst case. So ಇಲ್ಲಿ ನಾವು ಏನು ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕು average case find out ಮಾಡೋಕೆ time taken for all possible cases. So ಇಲ್ಲಿ ನಮ್ದು possible cases ಏನಾಗುತ್ತೆ given arrayದಲ್ಲಿ from 1 to n as there are nth indexes. Time taken for all possible cases divided by number of cases. So ಇಲ್ಲಿ ನಮ್ಮ number of cases ಏನಿದೆ 1 ಇದೆ, ಸಾರಿ n ಇದೆ, and all possible cases ಅಂತಂದ್ರೆ these are the comparisons. One comparison, second comparison at the second indexes, third comparison at the third index. So let me take this example. So comparison ಎಲ್ಲಿಂದ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ, ಫಸ್ಟ್ ಲಿಂದ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. ಫಸ್ಟ್ ಕಂಪ್ಯಾರಿಸನ್, ಸೆಕೆಂಡ್ ಕಂಪ್ಯಾರಿಸನ್, ಥರ್ಡ್ ಕಂಪ್ಯಾರಿಸನ್, ಫೋರ್ತ್ ಕಂಪ್ಯಾರಿಸನ್, ಫಿಫ್ತ್ ಕಂಪ್ಯಾರಿಸನ್, ಸಿಕ್ಸ್ತ್ and seventh, like this. So here the 7 is the size of the array. Likewise here 1 plus 2 plus 3, this summation expression, it represents the time taken for all possible cases divided by number of cases. So here the number of cases will be the size of the array. So in the numerator expression, as it is a summation expression, we know the formula of this expression, which is n into n plus 1 divided by 2 whole divided by n. So here n get cancels. What remains? N plus 1 by 2. Here we remove the constant terms for the average case, which is going to be big O of n. Okay students, so the average case efficiency of linear search is what? Which is also a linear function, that is big O of n. So what are the points to be remembered for algorithm analysis? These points are important for analyzing any algorithms. In subsequent units we will discuss various algorithms. So algorithms ಅನ್ನು ಅನಲೈಸ್ ಮಾಡಬೇಕಾದ್ರೆ ನಿಮಗೆ ಯಾವ ಯಾವ ಪಾಯಿಂಟ್ಸ್ ಅನ್ನು ನೀವು ನೆನಪಿಟ್ಕೋಬೇಕು ಅನ್ನೋದನ್ನ ಇಲ್ಲಿ ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. What is the first point to be remembered? Both time and space efficiencies are measured as function of algorithms input size. So algorithm analysis ಮಾಡಬೇಕಾದ್ರೆ two important factors ಏನಿದೆ, time and space. So time efficiency and space efficiency. So our time and space efficiency ನಾವು ಎದರಲ್ಲಿ ಮೆಜರ್ ಮಾಡ್ತೀವಿ? We measure that as functions of algorithms input size. And time efficiency is measured by counting the number of times the algorithm's basic operation is executed. So ಯಾವುದೇ ಒಂದು algorithm ಇದೆ ಅಂತಂದ್ರೆ ಆ algorithm ಇಲ್ಲರ ಬೇಸಿಕ್ ಆಪರೇಷನ್ ಅನ್ನು ಎಷ್ಟು ಟೈಮ್ಸ್ ಎಕ್ಸಿಕ್ಯೂಟ್ ಆಗಿದೆ ಅಂತ ಅನ್ನೋದನ್ನ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಇದರ ಬಗ್ಗೆ ಡೀಟೇಲ್ ಆಗಿ ನಾವು ಸೆಕೆಂಡ್ ಸೆಷನ್ ಅಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. And space efficiency is measured by counting the number of extra memory units consumed by the algorithm. So ಎಷ್ಟು ಮೆಮೊರಿಯನ್ನು ಯುಟಿಲೈಸ್ ಆಗುತ್ತೆ ಅದನ್ನು ನಾವು ಸ್ಪೇಸ್ ಎಫಿಷಿಯನ್ಸಿಯಲ್ಲಿ ಮೆಜರ್ ಮಾಡ್ತೀವಿ. Hence the efficiencies of some algorithms may differ significantly for inputs of same size. So ಒಂದೇ ಇನ್ಪುಟ್ ಗೆ ಬೇರೆ ಬೇರೆ ಅಲ್ಗಾರಿಥಮ್ಸ್ ಎಫಿಷಿಯನ್ಸಿಯನ್ನು ಚೇಂಜ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. For such algorithms we need to distinguish between the worst case, average case and best case efficiencies. Okay students, so in today's session we discussed about orders of growth of various functions and worst case, best case and average case efficiency with the help of linear search algorithm. Now let us discuss MCQ session, multiple choice questions. Now let us start the MCQ session. Read the following statements. What is the first statement? Order of growth varies from function to function for an input size. Second statement, algorithms that require an exponential number of operations are practical for solving only problem of very small sizes. Which of the above statement is correct or correct? So given ಎರಡು ಸ್ಟೇಟ್ಮೆಂಟ್ ಅಲ್ಲಿ ಯಾವ ಸ್ಟೇಟ್ಮೆಂಟ್ ಅನ್ನು ಕರೆಕ್ಟ್ ಇದೆ ಅಂತ ಅನ್ನೋದು ಕ್ವಶನ್ ಇದೆ. ಸೊ ಆರ್ಡರ್ ಆಫ್ ಗ್ರೋತ್ ವೇರೀಸ್ ಫ್ರಮ್ ಫಂಕ್ಷನ್ ಟು ಫಂಕ್ಷನ್. ಯಾವುದೇ ಒಂದು ಫಂಕ್ಷನ್ ಆರ್ಡರ್ ಎದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ, ಇನ್ಪುಟ್ ಸೈಜ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. ಹ್ಯಾನ್ಸ್ ಫಸ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಕರೆಕ್ಟ್ ಇದೆ. ವಾಟ್ ಅಬೌಟ್ ಸೆಕೆಂಡ್ ಸ್ಟೇಟ್ಮೆಂಟ್? Algorithms that require an exponential number of operations are practical for solving only problems of very small size. Second is also correct. How? Let me take the factorial example. So factorial example, 10 input value ಕೊಟ್ಟಾಗೆ, small input ಕೊಟ್ಟಾಗೆ ಏನಾಗಿದೆ? We got 10 to the power of 6 values as output. So small values ಮಾತ್ರ exponential functions ಅನ್ನ ವರ್ಕ್ ಆಗುತ್ತೆ. So both 1 and 2 are correct. So the solution is C. Now let us see the second question. Which of the following function has slowest growth? Given 4 function ನಲ್ಲಿ ಯಾವ ಒಂದು ಫಂಕ್ಷನ್ ಸ್ಲೋಯೆಸ್ಟ್ ಗ್ರೋತ್ ಇದೆ ಅನ್ನೋದು ಕ್ವಶನ್ ಇದೆ. ಸೊ ನೀವು ಆ ಟೇಬಲ್ ಅನ್ನು ನೆನಪಿಟ್ಕೊಂಡ್ರೆ ಅಥವಾ ಟೇಬಲ್ ಅನ್ನು ನೀವು ವ್ಯಾಲ್ಯೂಸ್ ಅನ್ನು ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ you will come to know the functions which is having the slowest growth. So here you observe it. So for a logarithmic function we are getting the lower values compared to other functions. Hence the answer will be logarithmic function. So for this question, let us see the answer. Option C, which is logarithmic function. Let us see the third question. Which of the following functions has fastest growth? So table ಇಂದ ನೀವು observe ಮಾಡಿದರೆ ನಿಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ factorial function is having the fastest growth. Let me see the answer. Option D, which is n factorial. Read the fourth question. Which of the following cases are considered while measuring the efficiency of algorithms? So second concept ಏನಿತ್ತು ನಮ್ದು ಇವತ್ತಿನ ಸೆಷನ್ದು ವರ್ಸ್ಟ್ ಕೇಸ್, ಬೆಸ್ಟ್ ಕೇಸ್ ಅಂಡ್ ಎವರೇಜ್ ಕೇಸ್. ಯಾವುದೇ ಒಂದು ಅಲ್ಗೋರಿದಮ್ ಎಫಿಷಿಯನ್ಸಿ ನಾವು ಮೆಜರ್ ಮಾಡಬೇಕಾಗಿತ್ತಂದ್ರೆ ವಿ ಕನ್ಸಿಡರ್ ಆಲ್ 3 cases, that is worst case, best case and average case. Hence what will be the answer, students? D will be the answer, all of the above. Read the fifth question. Consider the following statements with respect to linear search. If search is not found, then we can apply worst case efficiency, right? So what is the worst case efficiency? It is the maximum number of steps taken to run the algorithm. So linear search ಅಲ್ಲಿ worst case ಯಾವಾಗ ಆಗುತ್ತೆ? ಒಂದು matching happens at the last position of the array, or if there is no matching. Hence first statement ಏನಾಗುತ್ತೆ? Correct ಆಗುತ್ತೆ. What is second statement? Best case efficiency is the efficiency where search key is matches at last element of the array. No. Search key matches at the first element of the array. So second statement wrong ಆಗುತ್ತೆ. What about third one? Average case efficiency is the average case of best and worst case. So average case lies between the best and worst case. Hence the options will be first and third statements are correct. So which is the correct option? Third, C. First and third are the correct statement. Let me see the answer. Yes, C is the correct answer. Read the sixth question. Worst case efficiency of linear search. Linear search worst case efficiency ಏನಿರುತ್ತೆ? That is n, maximum number of steps taken to search the given key, which is n. Option is B. Best case efficiency of linear search. Best case efficiency of linear search ಏನಿದೆ? Which is a constant term. Matching happens at the first position only. Hence, option A is correct. Okay, students. Now come to the ninth question. Average case efficiency. Average case efficiency of linear search is what? 1, n, n plus 1 by 2, none of the above. ಯಾವುದಿತ್ತು ಆನ್ಸರ್? n. n is the average case efficiency of linear search. Let me see the answer. B is the correct answer. So these are some assignment questions. Explain orders of growth of functions with at least 2 examples. Define worst case, best case, and average case efficiencies. And explain worst case, best case, and average case efficiency of linear search algorithm. So here it is a references for your kind information. Okay, students, thank you for watching this video. Thank you once again.